In this session, we're going to see about combinations and ways of counting. Combinations can be used if we are, for instance, forming a committee of people that don't have titles. For example, suppose we are asked, as we are here, how many three-person committees can be formed from a group of 10 people. This is not a committee that has titles. It's not president, vice president, it's just 3 people. So out of the 10 people, we could choose 3 of them, right? So you have 10 choices for the first person, and then 9 choices once what the first person is selected, and then 8 choices for the third person, and we might say that there are 720 total committees that can be formed. But that's not really true. Suppose the people that are chosen are Paul, Maria, and Jamal. Picking Paul first and then Maria and then Jamal is effectively the same thing as picking Maria first and then Jamal and then Paul. You see, they don't have titles there. It's not positions. It's just the 3 people that are going to, I don't know, represent you or go to a conference, or I don't know, whatever they're going to do, these 3 people. So it's actually the case that if we just consider these 3 people, then you have 3 choices for the first person that's chosen, 2 choices for the second person that's chosen, and 1 choice, of course, for the third person that's chosen. And so for these 3 people, there are actually 6 different ways that they could be chosen. What we would actually have to do is we'd have to take the 720 that we got from the original thought of 10 times 9 times 8, and we have to divide out the repetition that is obtained by selecting these people in a different order. So we'd actually have to divide by 6. And so in this case, there would be actually 120 different committees because, again, they don't have titles. And so this is a situation in which we would say order doesn't matter. And when we have titleless committees, or committee members, or whatever, or order doesn't matter, that's when we use combinations. The notation for this particular problem would be a combination, so uppercase C, of parentheses 10 comma 3. And the way it's computed is it's 10 factorial divided by the quantity of 10 minus 3 factorial. But then we have to have an additional factor in the denominator, or factors, of 3 factorial, right? So the 3 factorial is to divide out the repetition because order doesn't matter. And the reason, by the way, that 3 factorial is the magic number is because 3 factorial is the 3 times 2 times 1 that we've referenced earlier. And this computation actually simplifies, so we have like 10 factorial divided by 7 factorial times 3 factorial. And as you may notice, this 7 plus 3 adds up to the 10 that we have in the numerator. That's always going to be the case with combinations. In fact, in general, we would say that a combination of n things taken r at a time is n factorial divided by the quantity of n minus r factorial times r factorial. And you see, of course, if you add those 2 things together, n minus r plus r, you get n. So that's just inherent in the formula for combinations. And there should be a button in your calculator, your scientific calculator, that looks like NCR. And in this case, we would have done like, 10C3. And some people would refer to this as 10 choose 3. I don't know why they say choose, whatever. Anyway, the answer here is 120 committees are possible. Okay, let's look at the next example here. A lottery is held in which players select 6 numbers between 1 and 49. How many such selections are possible? Now, since it doesn't matter which number a lottery player selects first, order doesn't matter. That is, it doesn't matter in what order this player selects the numbers on his ticket or her ticket. It just, at the end of the day, 6 numbers are chosen. So since order doesn't matter, we're going to use a combination. And this is actually going to be 49, choose 6. Or another way to write it is C parentheses 49 comma 6. Yet another way to write it, and this one's a little weird, it's parenthesis 49 over 6, but no fraction bar. And without that fraction bar, this means a combination. And so all of these three things mean the same thing. And you can put this in your calculator, but of course, we're going to emphasize the formula here, and that is going to be 49 factorial divided by 49 minus 6, that quantity factorial, times 6 factorial. And so this actually simplifies to 49 factorial divided by 43 factorial times 6 factorial. And my calculator tells me that 1,398,316 selections are possible. Gee, you think I'm going to win? Now this idea of dividing out the repetition is extended in this next example, which is how many ways can the letters in Tennessee be arranged? Well, okay, so order kind of matters, but order kind of doesn't matter. Here's the deal. If I switch the places of the two N's, I don't have a different word, right? If I switch the places of the two S's, I don't have a different word. So what we're going to do is we're going to count how many letters are there in Tennessee. There are 9 letters total. And so we can consider for the first letter to be selected, say out of a bag with all of these letters in the little Scrabble tiles, let's say. There are 9 possibilities. And then once that one's selected, 8 possibilities left, and then 7 possibilities, and so on, all the way down until you get the last one, right? So that's actually 9 factorial. So that's where we're going to start, 9 factorial. But there are 4 E's, and the order of those makes no matter, right? Wherever they are, one E is the same as another E. And so we're actually going to have to divide out 4 factorial to account for the 4 E's that are present. And then there are 2 N's, and so we actually have to divide by 2 factorial, which is the same as dividing by 2, but we'll keep going. And then there are 2 S's, and so we have to divide again by 2 factorial. So actually our answer is 9 factorial divided by the quantity of 4 factorial times 2 factorial times 2 factorial. Now there's no fancy calculator button for this. There's no fancy name for it. It's just being aware of what's going on. And you'll notice that I put parentheses around the 4 factorial times 2 factorial times 2 factorial in the denominator because that's how you have to enter it into your calculator. And when I do that with mine, I get 3,780. So they can be arranged in 3,780 ways. And this is kind of like combinations on crack.